Alright, it's been a long time since my last video, so I figured it's about time to get back into it and make another ECG video. I mentioned in one of my older videos that I think the insulation on the wires that I'm using for my electrodes is piezoelectric, which means it generates a voltage when I rub it or hit it. And if that's the case, I should be able to use the cable itself as a microphone to pick up sound. So in this video, I'm just going to just play around and see what I can do with it. So here's the setup for this video. I've drawn the entire ECG circuit just as a single amplifier with its plus and minus inputs and its ground reference coming out. Then I have a long stretch of cable going to these two 1 mega ohm resistors which simulate the resistance of my body. I think I mentioned this in a previous video, but the reason I have these resistors here is because the ECG is a voltage amplifier, not a current amplifier. So when I rub the cable here, and that causes a current to flow, the current will flow through these resistors and cause a voltage drop, which is picked up and amplified by the ECG. So let's take a look at what I've got set up here. I've got the ECG connected to the computer like always. Then I have that alligator clipped onto the cable, which is just wound up into a little circle and then taped down to the desk so it doesn't move around. Then some more alligator clips to a couple of 1 mega ohm resistors. Nothing too fancy there. Now it's been a long time since I've had all this set up, so the first thing I'm going to do before I start playing around is try to replicate the original problem. So let's get this turned on and start recording. That looks like a bunch of 60 hertz. Let's play around with this cable here and then take a listen to it anyway to see what's in there. Alright, so it sounds like it still works, and there's also a lot of 60 hertz on there. If I'm going to use this as a microphone, I'm going to want to get rid of all that 60 hertz first, otherwise it's just going to drown out anything it picks up. So all of that 60 hertz usually comes from a bad common mode rejection in my amplifier. And that bad common mode rejection could be coming from bad connection in these alligator clips. So these alligator clips seem to be biting down hard enough. Another thing could be just an imbalance in either the circuit, which I've tuned out previously with that common mode adjustment knob. It could also be caused by an imbalance in these two resistors that I have on the end here. So these resistors are 5% tolerance, so there is going to be some difference between the two. And a difference in resistance in these two paths is going to cause a difference in the voltage drop between these two paths when 60 hertz couples in from the walls. So it does seem to change a lot when I start messing with these things and wiggling them around, but it's not really consistent. I think what I need is some way to adjust it, and I think a potentiometer like this is the way to do it. So this guy, I think, is only 100 kilo ohms, so it's not the 1 mega ohm I have on each end. It's going to end up being only 50 kilo ohms on each end, but at least it will be adjustable, and I can adjust the balance. All right, let's try this. So I should be able to turn this knob and hopefully, oh, there we go. Yeah, so when I turn this and get it just right, I can balance the two sides and get much less of that 60 hertz noise. Oop, a little bit too far. I think that's about as good as I'll get it. That looks much nicer. Oh, hold on. Whenever I move the mouse, I get some more stuff in it. Let's see what that sounds like. That's kind of neat. So this is also picking up data from my mouse. That would be an interesting side project to record the mouse through the sound card and then try to pick out the packets and recreate the mouse movements. Now that I have that common mode adjusted, let's rub the cable. So I think I'm good to go, and I'm ready to start actually doing some science with it. So now onto the actual science. So I've got an old project here, which is just an audio amplifier driving a speaker, and that is driven by my phone, which is putting out a 1 kilohertz test tone, because we're being all scientific here. Now I could use the speakers on my computer for this experiment, but as we've already seen, the microphone input will pick up data from the mouse movements. If it can pick up data from the mouse movements, it might also pick up leakage directly from the audio output. And if I have any leakage going directly from the audio output to the microphone, I would not be able to tell the difference between that and sound coming out of the speaker and then into my microphone cable. So just to remove bad sound card isolation from the equation using a separate sound source. Now the idea here is to put the speaker directly on the cable and record through the ECG and see if it picks it up. But there is a big old coil in the speaker, which is going to have a big old magnetic field around it, and we don't want that to get picked up by the cable here, because then we have transformer coupling of the sound into the ECG instead of the acoustic, I guess mechanical coupling into the insulation. So that should hopefully not be a problem, because the loop that the magnetic field will need to pass through is between the blue wire and the yellow wire, and they're all twisted up together, so there's no space in between them for the magnetic field to get through. But still, just to make sure that's not the case, I'm going to do a couple of tests, one with the speaker directly on it, and one with the speaker just a little bit above it. So the amount of actual mechanical coupling will be different, but the amount of transformer coupling will be about the same. So if the sound I'm picking up is the same between these two cases, then I can say it's probably due to some transformer coupling. All right, so now I'm recording. I've got no 60 hertz noise on there, that's good. Start playing the sound, and let's put this over there. All right, so it is picking up something. Let's see what that sounds like first of all. Oh, it's definitely in there. The question is that transformer coupling, or is it actually being picked up by the insulation? So I was playing a lot with the direction the speaker was facing and where I was holding it over the cable, but I really don't think this is a good test, just because there's no obvious difference between having the speaker directly on it, having the speaker just above it, and the amount that it picks up seems to be dependent on a lot of other different things. So I'm going to try and think of something else to test this with. So I think there was too much electromagnetic transformer type of coupling between the speaker and the wire for that to be a good test. So in order to get more scientific, I built a kazoo. So with this guy, there's no magnetic field, obviously, and plenty of vibration to couple into the insulation of the cable. So if anything proves that the insulation on those wires is piezoelectric, this will do it. So for this test, I've got the cable up off the table, just taped on this multimeter, and then I'll just blow my little kazoo at it while I'm recording and see what happens. Now let's see what that sounds like. So I didn't hear anything there, and now I also have a clicking noise in there, which I didn't hear before when I had the cable taped down to the table. I really don't know what that clicking noise is, but I'll just move on for now and figure that out later. Alright, now I've taped the cable to the end of the kazoo, so there will definitely be some vibrations coming from the kazoo going to the cable. So this will definitely do it, if anything does it at all. Let's try it out. Well, there we go, that's it. Now let's see what kind of quality we can get out of this.
The white zone is for immediate loading and unloading of passengers only. There is no stopping in the red zone.
Alright, I was not really happy with the results that time, so I've taped down the diaphragm of the kazoo instead of rubber banding it down, so it's a lot tighter now, so there should be some better vibration going on. Let's try this and see what happens.
The red zone is for immediate loading and unloading of passengers only. There is no stopping in the white zone.
The red zone is for immediate loading and unloading of passengers only.
So I'm happy with that. That actually wasn't too bad of quality. So I'm going to call this great success, and I think that definitely proves that this insulation, whatever it is on these wires, is piezoelectric. So I think that means one way of solving this problem would be to use an audio cable like this as my electrode cable, since the insulation on the individual wires is buried inside that outside insulation. It'll be harder to for the vibrations to get to it. And also, since it's an audio cable, I expect they would have designed it to not actually pick up audio. So I think I've mentioned that idea in a previous video, but now that it's definitely seeming like a good way to go for the next video. There's also the matter of that clicking that was in the background when I was recording with the kazoo. The only difference in the setup between that and the previous test that didn't have the clicking was that the cable was not taped down to the table in that test. So the circuit itself and the setup of all the electrical bits was the same. So I don't think it's my circuit oscillating or anything. But I also don't know what it is. So I'll look into that more, and if I find a good answer, I'll make another video about it. This is also kind of interesting from a security perspective. You might actually be able to do some Tempest-style eavesdropping. The twist-a-pair in phone cables or Ethernet cables, I don't know if they have the same kind of insulation, but it might be similar, and it might have a similar effect. So it might be possible to just plug in an amplifier to a jack in another room and eavesdrop on somebody's conversation. So that's it for this video. It's not progress towards the finished ECG, but I did learn a bit and did some interesting things with it. In the next video, I'll probably talk about RF filtering to remove some of the radio that I picked up in past videos.